So I have now three integrals I need to compute. The first one starts simply by just asking for the integral from 1 to 5 of dx, or just 1 dx, right? It's as if I had a 1 multiplying here, and the consequence of that is that I have the function y equals to 1, so this is a constant function at height 1, and I'm integrating that from 1 to 5, so that for me would be the area. That's what the integral wants. Area of this guy, and the area here is base, right? 5 minus 1, that's 4, times height, which is 1. So 4, that is the answer. Or if you want to use the fundamental theorem of calculus, you can also do that. You can say, that this is the antiderivative of 1, which is x at 5 minus x at 1. So 5 minus 1, 4. On B, we are now actually using the fundamental theorem of calculus. So we're doing an antiderivative here for x to the 22 over 22. So adding 1 to the power and dividing by 22, that's what's called the reverse power rule. You add 1 to the power and then divide by that power, which is the opposite, right? The reverse of what you did for derivatives. With derivatives, you bring the power down, subtract by 1, and then multiply by that power you brought down. So here you're first adding 1 to the power and then dividing. So the 21 plus 1 is 22, and then divide by that 22. Do the same with the 16. That's 2x to the 17, add 1, and then divide by the 17. 1 is just x. The derivative of x is just 1. So the antiderivative of 1 is just x. Remember that we also have to evaluate this from 0 to 1. So that means we're calculating, plugging in 1. 1 to the 22nd is just 1. 1 to the 17th is just 1. And then minus, evaluate 0 on this. Right? When you plug in 0, this is going to be 4 times 0 divided by 22. That's going to be a 0. That's going to be another 0. That's going to be another 0. So my answer, I should use a calculator to figure out what that is. And since the question is asking for me to round this to 3 decimal places, you should be able to figure it out pretty easily. Now on C, this looks like a monster. It's pretty difficult to do this manually, to do this by actually using the reverse power rule on that one, doing that 18 dividing by 1, and also noting that you need to plug in 3 and negative 3. But that is, if you were to do that, that would be unnecessary work, because if you note all powers here, except for the last one, they're odd powers. So this is a polynomial that has only odd powers except for the last one. And conveniently, this guy and this guy, they're symmetrical across the x-axis. So what is going on, right? This is the integral from minus 3 to 3 of an odd function. And it's all of this dx plus an integral from minus 3 to 3 of x squared dx. The odd function part, if you remember that odd functions are symmetrical across the origin, and your interval goes from minus 3 to positive 3, this area right here is exactly the same as this area right here. And because this one is above the x-axis, it's positive, receives positive weight. This one is below, receives negative weight. So when I add the two, the net area equals to 0. So this integral is 0. That is a time-saving tip right there. And now all I need to do is integrate this to find out what the answer is. So this is x cubed over 3, but then evaluated from minus 3 to 3. So when I plug in the 3, that is 27. So 3 cubed over 3. Correct? So 3 times 3 times 3 minus, plug in the minus 3, and I'll get a minus 27 over 3. So that will be A. Positive 9 plus another 9. So that would be an 18. So no need to round here because the answer is an exact number. Always try to box your answers and indicate them where possible. Here I didn't box anything because I didn't write down the answer using 3 decimal places, but here I did. So make sure always box or circle or underline your answers whenever you're done with a question.